The National Electrical Code, or NEC, defines readily accessible as being capable of being reached quickly for operation, renewal, or inspections, without requiring those to whom ready access is requisite to climb over or remove obstacles or to resort to portable ladders. In many instances, a yard pole with a meter main is not considered readily accessible for a residential home. This is due to several reasons. Firstly, the distance from the house. The yard pole could be a considerable distance away, making it difficult to reach quickly in case of an emergency or for maintenance. Secondly, weather conditions. In areas with heavy snowfall, accessing the yard pole might be impossible or dangerous during winter months. When a yard pole main disconnect isn't deemed readily accessible, there are alternative options to consider. An exterior disconnect can be installed on the building. A disconnect switch can be installed on the exterior of the home, close to the point of entrance of the conductors. Alternatively, if no exterior disconnect is installed, the panel board nearest to the service entrance should have a main breaker to serve as the main disconnect. Furthermore, in some jurisdictions, a fuse block with the appropriate amperage rating can be used as a main disconnect within the panel board. Regardless of the location of the main disconnect, proper grounding and bonding must be ensured. This includes bonding the UFA ground, water pipe, and all other grounding electrodes to the grounding electrode conductor and the neutral bus of the service entrance. While a yard pole main disconnect may be acceptable in some cases, it is generally not considered readily accessible for residential homes. For homes outside of city limits where there is no electrical inspection, it is recommended to provide an exterior disconnect mounted in the built-in or a main breaker in the panel nearest to the point of entry of the conductors to ensure compliance with the NEC and local amendments requiring a readily accessible main disconnect. Let's delve into the specific requirements and considerations for main disconnects in residential electrical systems. The NEC provides comprehensive guidelines to ensure safety and accessibility. Understanding these guidelines is crucial for electrical contractors, inspectors, and homeowners. Firstly, let's clarify the purpose of a main disconnect. Its primary function is to provide a means to quickly and safely to energize the entire electrical system in a building. This is essential for maintenance, repairs, and emergency situations. The location and accessibility of the main disconnect are paramount. The NEC mandates that it be readily accessible, meaning it must be easily reachable without the need for tools, ladders, or the removal of obstacles. In the context of residential homes, the debate often arises regarding the suitability of a meter main located on a yard pole as the main disconnect. While this configuration may be permissible in some jurisdictions, it presents several challenges concerning accessibility. Consider a scenario where a homeowner needs to quickly shut off power due to a fire or electrical hazard. If the meter main is located on a yard pole a significant distance from the house, reaching it promptly could be difficult or impossible, especially in adverse weather conditions. Snow, ice, or heavy rain could impede access, potentially delaying critical safety measures. Furthermore, the NEC emphasizes the importance of having a readily accessible disconnect for inspection and maintenance purposes. Electrical inspectors and technicians need to be able to easily verify the integrity of the electrical system and perform necessary repairs. If the main disconnect is located on a remote yard pole, it may pose logistical challenges for these activities. Therefore, in many cases, an exterior disconnect mounted on the building is the preferred solution. This configuration places the disconnect within easy reach of the homeowner and emergency responders, ensuring a swift and safe response in critical situations. The exterior disconnect should be clearly labeled and readily identifiable. Its enclosure must be weather resistant to protect it from the elements. Alternatively, a main breaker in the panel board nearest to the service entrance can serve as the main disconnect. This option is particularly suitable for homes where an exterior disconnect is not feasible or desirable. The main breaker must be clearly marked and easily accessible within the panel board. It should have sufficient interrupting capacity to handle the maximum available fault current. Regardless of the location of the main disconnect, proper grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to return to the source, tripping the circuit breaker or fuse and preventing electrical shock. Bonding ensures that all metallic parts of the electrical system are at the same potential, minimizing the risk of stray voltage and electric shock hazards. The NEC specifies detailed requirements for grounding and bonding, including the size and type of grounding conductors, the location of grounding electrodes, and the methods for bonding metallic components. Common grounding electrodes include ground rods, metal water pipes, and concrete encased electrodes, also known as UFA grounds. These electrodes must be properly connected to the grounding electrode conductor, which runs to the main service panel. Within the main service panel, the grounding electrode conductor is connected to the neutral bus, creating a solid connection between the electrical system and the earth. In addition to grounding, bonding is crucial for preventing electrical shock hazards. Bonding involves connecting all metallic parts of the electrical system, such as metal conduit, metal enclosures, and metal water pipes, to the grounding system. This ensures that all metallic parts are at the same potential, eliminating the risk of voltage differences that could cause electric shock. The NEC provides specific guidelines for bonding different types of metallic components. For example, metal water pipes must be bonded within 5 feet of their point of entry into the building. Metal conduit must be bonded at each end and at intervals not exceeding 100 feet. The size of the bonding conductors depends on the size of the service entrance conductors. It is important to note that grounding and bonding are not the same thing, although they are often used interchangeably. Grounding provides a path for fault current to return to the source, while bonding ensures that all metallic parts are at the same potential. Both are essential for electrical safety and must be properly installed and maintained. When evaluating the suitability of a yard pole main disconnect, several factors should be considered. Firstly, distance. Is the yard pole located a reasonable distance from the house, allowing for quick and easy access in emergencies? Secondly, weather conditions. Are there any weather-related obstacles that could impede access to the yard pole, such as heavy snow or ice? Thirdly, local regulations. Do local codes or amendments require an exterior disconnect on the building regardless of the presence of a yard pole main disconnect? If the answer to any of these questions is no, then an alternative disconnect solution should be considered. An exterior disconnect mounted on the building offers several advantages over a yard pole main disconnect. It is readily accessible in all weather conditions, it is located within easy reach of the homeowner and emergency responders, and it provides a clear and unambiguous point of disconnection for the entire electrical system. When installing an exterior disconnect, it is important to choose a location that is easily visible and accessible. The disconnect should be mounted at a convenient height, typically between 4 and 6 feet above the ground. It should be protected from physical damage and exposure to the elements. The disconnect enclosure must be weather resistant and listed for outdoor use. The disconnect switch or breaker must be properly sized to handle the maximum load of the electrical system. It should be clearly labeled to indicate its purpose as the main disconnect. In addition to an exterior disconnect, a main breaker in the panel board nearest to the service entrance can also serve as the main disconnect. This option is particularly suitable for homes where an exterior disconnect is not feasible or desirable. The main breaker must be clearly marked and easily accessible within the panel board. It should have sufficient interrupting capacity to handle the maximum available fault current. When using a main breaker as the main disconnect, it is important to ensure that the panel board is located in a readily accessible location. The panel board should not be obstructed by furniture, appliances, or other objects. It should be well lit and easily identifiable. The panel board cover should be securely fastened and labeled with the names of the circuits it serves. Regardless of the type of main disconnect used, it is essential to have it inspected by a qualified electrical inspector. The inspector will verify that the disconnect is properly installed, sized, and labeled. They will also check the grounding and bonding system to ensure that it meets the requirements of the NEC. Regular electrical inspections are crucial for maintaining the safety of your home's electrical system. Inspections can identify potential hazards before they cause problems such as loose connections, damaged wiring, or overloaded circuits. If you are unsure about any aspect of your home's electrical system, It is always best to consult with a qualified electrical contractor. A qualified contractor can assess your electrical needs, recommend appropriate solutions, and ensure that all work is performed in accordance with the NEC and local codes. In conclusion, the selection and installation of a main disconnect for a residential home require careful consideration of the NEC requirements and local codes. While a yard pole main disconnect may be acceptable in some cases, it is generally not considered readily accessible. An exterior disconnect mounted on the building or a main breaker in the panel board nearest to the service entrance are often better solutions, providing a readily accessible and reliable means of disconnecting the entire electrical system. Proper grounding and bonding are essential for electrical safety and must be properly installed and maintained. Regular electrical inspections are crucial for identifying and addressing potential hazards. By following these guidelines, you can ensure the safety and reliability of your home's electrical system. Moreover, it's also important to consider future expansion. As your energy demands change, make sure to leave room to add new circuit breakers if you anticipate adding any electric vehicle chargers, hot tubs, or equipment that requires a significant amount of power. This is often done by installing a main panel that has more slots that are initially needed. This panel can always be replaced with a larger one, but it will cost less money if you plan ahead. Be aware that some local municipalities might want you to use licensed contractors when it comes to adding new circuit breakers, so it is worthwhile to check first before you do anything. There are also new electrical devices that are constantly being developed, and it can be helpful to consult an electrical expert before you invest in any of them. For example, there are arc fault circuit interrupters, RFCs, that are designed to protect against fires caused by electrical arcs. There are also ground fault circuit interrupters, or GFCIs, which protect against electrical shock. It is important to understand the difference between these devices and to install them in the appropriate locations. Furthermore, electrical codes and standards are not static, they evolve to reflect new technologies, safety concerns, and best practices. Staying abreast of these changes is crucial for electrical professionals and homeowners alike. Regular training, continuing education, and participation in industry events can help you stay informed and ensure that your electrical work is always up to code. Access to the latest edition of the NEC and any applicable local amendments is essential. These documents provide detailed guidance on all aspects of electrical installation, from wiring methods to equipment specifications. In addition to the NEC, other standards and guidelines may apply to specific electrical installations. For example, the National Fire Protection Association, or NFPA, publishes standards on fire safety and electrical safety in the workplace. These standards may be referenced by local codes or adopted as best practices. In conclusion, ensuring the safety and compliance of residential electrical systems requires a comprehensive understanding of the NEC, local codes, and industry best practices. From selecting the appropriate main disconnect to implementing proper grounding and bonding techniques, every aspect of the installation must be carefully considered. By staying informed, seeking expert advice, and prioritizing safety, you can protect your home and family from the hazards of electricity. Finally, the location of the electrical panel is important. You should also think about how it looks. Often people redo their basement and cover the electrical panel with wood. This can be a code violation and can also make it hard to find when you need it most. Instead, try to keep the panel exposed so that it can be easily accessed. One of the ways that you can deal with an unsightly panel is to paint it. There are also decorative covers available that look like pictures or paintings that can cover an electrical panel in a more discreet way. Just be sure that the method that you use still allows for ready access, and be sure that it is not blocked by any furniture. Be sure that you never screw or nail anything directly into the panel, because this can be a major hazard. Lastly, it is important to regularly test your ground fault circuit interrupters. These are designed to protect you from electrical shock by shutting off the power when they detect a ground fault. To test them, press the test button on the front of the outlet. If the GFCI is working properly, it will trip and cut off the power. If it doesn't trip, it needs to be replaced.